Hi, and welcome back to another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes, you, Algebra 1. And this is our final exercise in this entire book, and if you've made it with us this far, thank you. Now, in exercise number 4, we have Brooke, and Brooke is tracking her savings over the last 5 years. She records the data in the table below. Based on this table, we want to know, should Brooke use a linear or an exponential regression to predict how much she will have in her savings after 10 years? Explain your reasoning. So this is another useful time when R values or correlation coefficients come in handy. Because based on our R values, it will tell us which R value is the more accurate way to measure a chart of data. Will it be a linear fit or an exponential fit? The one with the greater R value is the fit that most likely corresponds to this table. So what I mean by all of this is that we're going to need our calculators right here, and we're going to need to put our values into our tables, our list 1 and our list 2. So again, we're going to clear out anything that might be in there by highlighting the list and clicking on clear, then enter. And in list 1, we're going to put 1, 3, 4, 5, and 7. 1, 3, 4, 5, and 7. And over in list 2, we're going to put the savings in dollars that she had at those years: 300, 605, 860, 1,220, and finally 2,450. So now when we calculate a linear regression, we're going to go to calculate and a linear regression. We're going to go down to calculator. Remember, my diagnostics are turned on from my previous exercises. If you need to turn on your diagnostics because you don't have these R values when you click enter and calculate there, then you want to go to second 0 in your catalog, find diagnostic on, and press enter twice to turn them on. So now I have an R value of 0.947. So we'll round that up actually. We'll keep the 4 decimal places. 0. And we'll make a little note. So a linear is going to be R equals 0.9477. And now we want to find out what our exponential R value is to see how it compares to our linear one. And our linear one is pretty strong. It's very strong, actually, because it's anything 0.9 and above is a strong linear relationship. So now we want to just go back to stat, over to calculate, and now we're going to look for that exponential regression, which if you remember is down at choice 0, and we're going to press enter and go down to calculate there as well. And when you click on calculate there, wow, so that 0.94 over here is put to shame right now because we have 0.999999998. So we're just going to have 0. How many nines was that? Was that 5 or 6 nines? Because I can't round this one, because if I round it, it'll be round to 1. So 5 nines with an 8. So we have 5 nines with an 8. And if we compare these two, yes, the linear is very strong, but exponential is almost a perfect exponential relationship in this table right here. So should she use a linear exponential regression to predict? I would use exponential, because the R value is closer to 1. It's almost at 1. It's near perfect relationship, where this one could be thought of as it's 94.7% effective, and this one is 99.99% effective. So that's another way you can look at the R values too. So again, we would use exponential because the R value of that equation is closer to 1. So if this video was helpful, in order to distinguish whether you should use a linear or exponential regression model to predict a certain amount, then give this video a thumbs up to let me know that this was helpful to you. You have now finished your study of Algebra 1 using the Algebra 1 Next Generation Mathematics Workbook, and I wish you good luck in your future studies in other courses.